Hello there! Today we're going to be learning how to solve the 4x4 cube. In order to be able to solve this, all you need to do is to know how to solve the 3x3. Of course, the better you know how to solve 3x3 and your understanding of how the cube works and whatever will help you solve the 4x4 faster and easier. So let's go. So the first step in reduction method, which is what I'm showing you, is how to solve these centerpieces. So on a 3x3, of course, the centerpieces are only one piece, but on these cubes, they are 4 pieces. So you want to try and find the 4 white centers first. Of course, you can start with whatever color you want, but I'm going to start with white just for this video. And like on 3x3, if you solve white cross first, that does not necessarily mean you have to solve the white center first. For instance, if I find some blue pieces that are really easy to put together, I can do those centers first. But just for easiness, I'm going to start with white. So what you want to try and do is make bars with the pieces, and a bar means like 2 pieces together. So I can make this white bar, and then if these 2 pieces are connected, I can move one, or I can move one out of the way, and then move this center piece so it changes, and then when I move it back, it'll make a bar, and then I can connect those together. That should be pretty easy. You should be able to do that on your own. For now, you don't have to do the opposite side right away, but I will. So yellow is opposite white. So I already have a bar here, but I'm going to make these two a bar too, like this. And when I made that bar, it broke up my other center, so I want to move that bar out of the way so I can move this center back. So now I have 2 bars, and to put these 2 on the same side, you don't want to do this because that'll mess up these 2. So instead what you want to do is you actually want to put both of these yellow center bars right next to each other, so when you slice up, it'll knock this one out of the way. And the reasoning is that next you can move the center, this bar out of the way, and when you put this white bar back, it'll also put this yellow bar back. Now let's go for another center. This blue center is almost done, so I'm going to preserve this bar right here, and then I'm going to set this piece up so when I do an wide L, it'll pair these together. Next I can just put those together. Now you have to remember your color scheme for this. So if you solve the centers wrong, you won't be able to solve the cube. So make sure you solve your centers right. So here's blue, so orange is going to go on this side. So let's say I have an orange piece here, orange piece here. These can actually make a bar like this. And then I want to move these out of the way so I can just undo that move I did. Where are the other 2 pieces? Alright, the other 2 pieces are here. So, so I can move one of those orange pieces out of the way. Then I can move this orange piece by a U move to pair that bar together. And then finally, I can put this piece here simply by, again, I'm going to replace the other bar that was there. Then I'm going to move this orange one out of the way and put that other bar back. That will create the centers while keeping the other center together. Finally, or next, I should say, green goes here. And when you solve green, it'll also solve red, obviously. So this is a pretty difficult case, and it's kind of hard to figure out what to do here, but what you want to do is make a green bar, and you can do that by moving the red one up, and then moving the green one, and then bringing the green one back down. Finally, you have these 2 bars, so this is pretty easy. You can move the green bar to replace the other green bar, do a U2, and undo that move. Great, so that's centers. Next, we're going to be doing the edges. So for this, you probably want to pick a center row. You can't just go all across the cube. You can, you could if you want to, but I don't think you should do that. So this one edge is already paired. So we're going to move this out of the middle layer, and I'm just going to move that to the top. That won't mess up anything. So next, let's find an edge pair to do. Let's see. Alright, so I found this edge pair, blue and red and blue and red. And so I want to move both of these pieces into the middle layer. So the first one doesn't matter, you can move it however you want. But the second piece, you want to move it so that it's in the opposite slots. So this would be across and these would be opposites. So I can move that in like this. The other way you could move it in is like this, but that would be the wrong way. So I'm not going to do that. So here you have them across from each other, and then after that you can pair them up by doing a slice. And after you do that, you're going to move this edge pair to the top layer so it doesn't get broken up when you slice back. And you're simply just going to replace it with an unsolved edge pair. And then you can slice back and everything will be solved. Let's try that again. So let's see. These pieces are adjacent to each other and they need to be across from each other or opposite. So what I can do is I can either bring this piece out and put it back in the other way. That way they're across, and then you can slice over and replace it. Or in this case, since all these slots are free and there's no slicing going over, you can just do an R2, and that will actually pair them up opposite to each other. So you can do a wide U2 to pair them up. After that, you can replace it with an unpaired slot, and then you can do another U2 to replace the centers. Okay, let's try another one. So here is the orange and green piece, orange and green, so this one needs to go here. So I can put that one in like this. Next, I can pair these two together and replace it with an unsolved slot. Now as I see, when I slice back, these two are also going to be paired up, which is nice. And now this is the only unpaired slot left, so I'm going to move this piece up so that it knocks out a paired slot, and then I'm going to move the unpaired slot in, which will move this one back up, and that's how you will solve that. Now unfortunately you have a bit of a problem. So here there's white and red, here there's white and red, and they're both on opposite sides, so I can do a U2 to pair them together, but there's nowhere to put them on the top, because if you do that, it'll just replace it with another paired slot. Then if I make the centers whole again, then those won't be paired. So now what you can do is flip the cube over and use this as your U side. So now I have a bunch more unsolved pairs of edges that I can use to replace the things with. Okay, so now here's blue, here's the other blue one. So this blue one needs to come here. So if it's like this, I can use a sledgehammer to put it in, and then pair them up, put in a different edge and pair and slice back. Let's see what's up top here. So orange and yellow. So this orange and yellow one has to go here. Pair them up, and then like I did before, replace that solved one. Then I can bring this unsolved one over and put it back and reslice. Now there's another problem, which is there's nothing on this side and nothing on this side to replace. So that's when you get a bit of a dilemma. The way I do it is, let's say I have to do, I'm doing these two orange ones like so. What I can do is I can bring the edge that doesn't have a pair in it to the top and replace it with an already solved slot. Then when I create the slot, I can replace it with the unpaired slot, and when I slice back, this one will already be paired because it'll just go back to normal. Now I'm going to do an R2 to put these next to each other, and as you see, there's only two left. There's nothing to pair it up with, and that's when you need to do an algorithm. So I've been using this all video, but this is the flipping algorithm. It's really simple, and basically what you're doing is you're taking this pair out and you're flipping it. So this white yellow green piece is going to go here, and this yellow green piece is going to go here. So if you just take it out like this, and then you can do a sledgehammer to put it in the other way, or if it's like this, you can just take it out and put it in the other way like this. And if you want to know an algorithm for that, it's basically just doing a sexy move and then front, up, front. So finally, when these two are the same and these two are the same, you can do this algorithm. and that will pair them up. From here, the final step's really easy. You can solve this like a 3x3. So you have your centers, you have your edges, and you have your corners. So you can simply make a cross like this, and then go into F2L, or if you know beginner's method, then do whatever you need to do, and eventually you will get to PLL, which is where you might find another problem. So yes, when you get to PLL, you might get a case that looks like this, or like this, and basically that's when you have an odd number of edges solved, and on a normal Rubik's Cube you can only have an even number of edges solved, but here we have an odd number, and that means you have OLL parity. You get OLL parity about 50% of the time, and the algorithm to do it looks really long, but it's really not. So the algorithm is this. And so that will solve this last edge, and then you can go on with the rest of OLL like normal. Basically, in between all the moves, there's a U2. So all you really have to remember is wide R, then that rotation, then wide R again, wide R again, wide R prime, wide L prime, or wide L, wide R prime, wide R, wide R prime, wide R prime. So if you forget about the U moves, then it's pretty simple to do. Now finally you get to PLL, and if you don't know all the PLL cases, then you might not know this, but this is actually not a PLL algorithm. If you try and do this algorithm, you won't solve the cube. You'll have two of these non-solved things. So basically, just solve PLL like normal, and if you get this, then you just get it. And here's the algorithm for it, which will basically swap this piece and this piece. If you don't get that, you might also get something that looks like this, which is not a feasible case. Or you might get something like this, where there's two unsolved and two solved. So if you get these two that are unsolved, then you can hold it with one on the left and one on the front and do a normal U permutation. That'll get it to be across from each other like this. And so basically what you want to do now is this algorithm, and this is called PLL parity, and it goes like this. And that's pretty short, and then after that, of course, two more parts of the algorithm are to do U2 and UY2, but I think that's pretty self-explanatory. Also, you can do the algorithm before you finish PLL. And then after you do the algorithm, you'll get a PLL case that you will be able to recognize and execute. So that's all you need to know for 4x4. Centers, then pair the edges, then do 3x3 stage, and you might get OLL or PLL parity, and that's it.